Hey guys, today we're going to install all these components in here and build a powerful all-purpose PC, and I'm going to show you how to do it step by step. Let's get started. Hey guys, welcome to Elevated Systems. I'm your host, CJ. If you're new to the channel, welcome. If you're into all things tech, be sure to get subscribed so you don't miss all my future content. But today, I'm going to show you how to build a very powerful all-purpose PC that you can build today with available components and then add to in the hopefully near future when things like this GPU are available again. The agenda for this video is to first introduce and go over all the components we'll be using in the build. Then I'm going to show you how to assemble this PC step by step and connect the peripherals. Then, once the computer is up and running, I'll demonstrate the performance in some of the most common office productivity and content creation applications. After we see how capable the PC is without a graphics card, I'll show you how to upgrade the PC with a graphics card, unlocking a whole other level of performance and abilities. Now, I did skip some steps between assembly and performance overview, so for part 2 of this build, once the PC is assembled, I'll go over the UEFI settings, how to download and install Windows 10, and how to download and install all the drivers and utilities needed. I was planning to do all of this in a single video, but once I started filming B-roll and drafting the script, I realized the video would already be way too long and would probably just get buried by the YouTube algorithm. Part 1 is already a lot to cover, and it'd be great if you watched the whole video, but there are plenty of chapter markers below for those of you who want to skip around. Let's just get started and check out the components I've selected for this build. Now, as I go through these, there are some components that are integral to the build, then there are some that aren't 100% necessary, but I recommend. Then there's, well, at least one that's just for aesthetic purposes. And as I go through the parts, I'll also discuss alternatives. Let's start with the CPU. For this build, I've selected the Intel i5-10400. This is a 6-core, 12-thread CPU with a base frequency of 2.9 GHz and a max turbo frequency of 4.3 GHz. It also has integrated UHD graphics 630 with a max dynamic frequency of 1.1 GHz, which is the reason I selected this CPU. With the current worldwide shortage of graphics cards, it's almost impossible to buy one right now, and probably for the foreseeable future. So unlike AMD Ryzen CPUs that don't have integrated graphics, all Intel Core processors have iGPUs. Now, there is a caveat here. Any Intel F-skewed CPU like the 10400F, those don't have iGPUs. So if you see the i5-10400F for 15 to 20 bucks cheaper, don't buy it for this build unless you do already have a dedicated graphics card. Also, to head off the comments, the Ryzen G-skewed CPUs like the Ryzen 5 3400G have the onboard graphics. Unfortunately, just like graphics cards, you just can't find those available at a reasonable price. Moving on to the motherboard, and here we have the MSI B460 Torpedo. This is an entry-level motherboard on Intel's budget-level B460 chipset and has just enough features to be a good fit for this build while keeping it an affordable option. It's a socket 1200 board built for our 10th gen Intel CPU, and because the 10400 non-K is a lock CPU, the memory frequency is restricted to 2666 MHz on this motherboard. It also has 2 video outputs, 1 HDMI and 1 display port, 2 M.2 slots, and both USB 3.1 Gen 1 Type A and Type C front panel connections. Now, with all that said, Intel just announced that the H410 and B460 motherboards will not be compatible with 11th gen CPUs, which should be available within a couple weeks of this video posting. So if you may want to go with, say, the 11400, then you'll need an X490, or a new 500 series Intel motherboard. I'll leave links to those alternatives in the description. Now, the CPU does come with a stock Intel box cooler, which is perfectly adequate to cool the CPU, but I'm stepping it up to this Cooler Master Hyper 212 RGB Black Edition. Again, locked motherboard and locked CPU, so we can't overclock. However, two things. First, although the CPU can't exceed its 4.3 gigahertz boost frequency, the ability to reach 4.3 and the length of time it can stay there is determined by two things: the temperature and the available power. This tower cooler will keep the CPU cooler, therefore it could boost to its max frequency more often and stay there longer. Also, although the motherboard is locked and doesn't allow overclocking, MSI has given you the ability to increase the boost power limit from 134 watts to 255 watts, which is a bit more than the pancake cooler can handle. More power, more boost, more often, better performance. Also, the Intel cooler is just loud and ugly. Another choice is the Vetro V5. I actually reviewed this a little while ago, and it performs slightly better than the Hyper 212, and it's cheaper. But I only have the white one, which doesn't match this build at all. For memory, this is another option where there are many alternative choices, which is usually driven by what's available at the specific time you're looking. For this build, I'm going with a 32 gigabyte kit of G.Skill Trident Z RGB DDR4 3200 megahertz memory. Now, I just said this CPU and motherboard combo is limited to 2666 megahertz memory, so why spend more money on faster memory? Well, that's the thing. As memory speeds get faster, the older, slower memory becomes more rare and therefore more expensive. Supply and demand. So in the current market, I can find 3000 or 3200 megahertz kits for cheaper than 2666 megahertz kits. So it will only run at 2666 megahertz in this system, but I didn't waste any money on that performance hit. Plus, if you do upgrade to, say, a B560 motherboard, those do allow memory overclocking, so this kit will run at its rated XMP profile of 3200 megahertz. So I went with this because I got it for under $150 just a couple weeks ago. Unfortunately, it's up to about $180 today. As far as the capacity, I went with 32 gigabytes for a couple reasons. First, because you can get a good 32 gigabyte kit for under $150 nowadays. And second, because this PC will initially exist without a graphics card. The CPU and the iGPU will be sharing the physical memory. Having 32 gigabytes will allow you to dedicate much more of the RAM to the iGPU if needed, while still having at least 2 gigabytes of memory per CPU thread, which is the standard I typically try to meet. But this is now a bit more expensive than I think is warranted for this build, so I'll leave several options below. The important thing is that they all install the same way. Moving on to storage, I have a 1 terabyte Sabre Rocket Q M.2 NVMe SSD. This is a very capable drive. I did a full review of it if you want all the details. It'll get you up and running as a boot drive with plenty of room for software and personal files. There is a second M.2 slot on the board for future expansion, and of course, there's always the ability to add 2.5-inch SATA storage or even 3.5-inch hard drives for mass storage. For power, I have an EVGA BR450. It's a 450 watt, 80 plus bronze rated non-modular power supply. Another component where there are options. I'm going with the 450 watt PSU because it helps keep the overall budget down while being more than adequate for this system as built today and for my future upgrade goals. As I mentioned in the end of the video, I'll be adding a graphics card, a GTX 1660 to be precise, and that card recommends at least a 450 watt power supply. So as the graphics card typically has the most power demand in a PC, you usually base your PSU wattage on that. This is good for a GTX 1660, but if you have your eyes, for example, set on a RTX 3080, you're going to want something like a 750 watt power supply. So that's it for the core components, but before we get to the case, let me go over two things that will really help with this build and one that will just make it look better. First is a flexible ribbon Type-C USB 3 internal extension cable. And let me tell you, this little $8 cable will make connecting your front panel USB so much simpler and probably prevent you from tearing the pins off this motherboard. The second is this simple 3-fan splitter cable, allowing you to daisy chain the 3 case fans together, only needing to use 1 fan header on the motherboard. And finally, for aesthetic value, I have a set of inexpensive black cable extensions. I actually bought these for an earlier video, but they didn't arrive on time, and that video was my review of the case we're using today, the Fractal Meshify 2 Compact. Some of you may recognize this whole system as pretty much the same system I built in the Meshify 2 Compact as part of the review. In that video was just a 2-minute montage. Today we'll be doing the entire build step by step. So if you want to know everything there is to know about this case, be sure to check out my review on it. Finally, let's look at the peripherals I've selected for this PC. For the keyboard and mouse, I just went with a very inexpensive yet functional Logitech MK360 wireless keyboard and mouse combo. Nothing much to say, it's compact, it's functional, and it was only about $30 at my local Best Buy. I also grabbed this LG 24ML44B monitor while I was at Best Buy. This is a 24-inch 1920 by 1080 75Hz display. It's an IPS panel, so it has a wide viewing angle, but does only have a brightness level of 250 nits, which is on the lower end of average, and has a bit of a wide bezel, but at $109 was a good deal for a 24-inch display. Okay, so the big question, how much does all of this cost? I don't know. It depends on when you watch this video. At the time of filming, the PC as built, not including the peripherals, cost just over $800. Now, with the alternatives I've provided, you can bring that down to $650 or less. Again, that's today's prices. That could all change tomorrow. That's the problem with PC build guides in current times, and why I stay away from putting dollar values in the title or thumbnail anymore. But as built today, including the peripherals, you're looking at about $940 US. So let's get to it. Now, I have a workbench with a grounded anti-static mat and a fancy multi-bit tool set, but you can complete this build right at your kitchen or dining room table, and all you need is a number 2 Phillips screwdriver. You may also need a smaller one for the M.2 screw, which is pretty small, so number 0 Phillips screwdriver would be good too, and that's it. I'll start by opening up the case so it's ready for all the components. Set the case and all the panels aside for now. Let's begin installing our core components to the motherboard. Take the motherboard out of the box, along with the I/O shield and this small bag containing 3 M.2 screws. Remove the motherboard from the anti-static bag and place it on top of the box. The first component to install directly to the motherboard is the Sabre M.2 SSD. Remove the 2 screws securing the heat spreader and remove the heat spreader. And slide the drive into the slot at about a 30-degree angle. Once the drive is fully inserted into the slot, gently lower into place and secure it using one of the small M.2 screws. Finally, remove the film from the back of the heat spreader and screw it back in place. The next component we'll install is the CPU. To do this, press down slightly on this retaining bracket arm and slide it to the right until it's free of the retainer and lift the bar. Now lift the retaining bracket, revealing the CPU socket. Now, holding the CPU on either side, find the corner of the CPU with the small arrow and align it with the white dot on the motherboard. Now, lower the retaining bracket, keeping this notch behind the retaining bolt. Lower the retaining bracket arm, which will slide the bracket under the retaining bolt. The cover will pop off on its own. Finally, slide the arm under the retainer. To install the cooler, we'll begin by retrieving the hardware we'll need. Prep the backplate by inserting the flat top bolts labeled E in the instruction manual into the backplate and clip them in place with the plastic clips labeled I. Ensure the bolt is secured into the clip and the clip is positioned in the second notch. Do this for all four corners. Now, from the back side of the motherboard, position the backplate, passing the bolt threads through the 4 holes in the motherboard. Flip the motherboard back over and attach the nuts labeled F to the 4 bolts attached to the backplate. Use the provided socket to snug the nuts in place, but don't over tighten, potentially damaging the board. Now, attach the mounting brackets labeled B to the cooling tower using the 2 small screws labeled H, and remove the fan. Apply a pea-sized amount of thermal paste to the CPU, remove the sticker from the cold plate, and centering the cooler over the socket, lower it onto the CPU. Once you have each of the mounting bracket screws started, tighten them down a few turns at a time using a star pattern to ensure even mounting pressure on the CPU. These screws will bottom out once they're tight, so don't try to force them. Now you can reinstall the fan on the opposite side of the cooler from the rear I/O of the motherboard to ensure the airflow goes from the front to the back of the case. Finally, aligning the slot on the cable with the tab on the header, plug the CPU fan into the header labeled CPU1. Open up the 2 clips on each side of DIMMs A2 and B2. Then find the notch on the RAM and line it up with the catch on the DIMM slot. Now slide the memory module into the DIMM slot using firm, steady pressure. Push the RAM into the slot until the clips lock into place. Time to install the I/O shield. To install this, first determine how your motherboard's rear I/O is going to be positioned and orient the I/O shield in the same way. From the inside of the case, press the lip of the I/O shield into the opening in the rear of the case. Now we can install the motherboard. Line up the rear I/O with the corresponding opening on the I/O shield we just installed and carefully position the grounded mounting holes over the standoffs to correctly position the motherboard. Before securing the motherboard, connect the USB 3 extension cable to the right angle USB 3 header. If you don't have the extension, you'll need to connect the front panel USB 3 cable now, as it's almost impossible to do once the motherboard is secured in place without damaging the pins. Once it's in place, using 6 of these screws, secure the motherboard in place in these 6 locations. Screw the motherboard down until the screws are snug, but do not over tighten the screws. It's time to plug everything in, and I'll start with the HD audio cable. Pass the cable through the opening on the lower rear side of the case. These connections are keyed, meaning there's typically a plugged pinhole on the cable, which corresponds to a missing pin on the motherboard header. Line these 2 up and plug in the cable. Next, locate your fan splitter cable and route the female end through the same pass-through. Plug the cable into the header labeled SysFan2. Now locate the 4-pin RGB cable from the CPU cooler fan. We're going to plug this into the 4-pin header labeled JRGB2, aligning the arrow on the cable with the 12-volt pin on the bottom of the header. If you have a cable extension kit, locate the 24-pin ATX cable extension and the 4+4-pin CPU power cable extension. Now, aligning the latch on the cable with the catch on the header, plug in the 24-pin cable, passing the other end of the cable through the adjacent grommet. Do the same thing for the CPU power cable on the top rear of the motherboard. Locate the header labeled JFP1. Begin by plugging the wire labeled Power LED Plus into the top left pin, the Power LED Minus into the next pin to the right. The reset switch plugs into the 3rd and 4th pin from the bottom left, and finally the power switch just above that. The final cable to plug in is the USB-C cable, so pass it through the grommet just below the 24-pin cable and plug it into the header labeled JUSB1. Now it's time to install the power supply, so remove the PSU bracket from the rear of the case. Using these screws, loosely attach the bracket to the power supply. Keeping the mounting screws loose will allow you to adjust the bracket when reattaching it to the case. Now with the fan facing down, feed the PSU cables through the rear of the case and securing the HD audio and fan cables so you don't rip them from the motherboard, slide the PSU into the case. Secure the bracket to the case and finally tighten the mounting screws. It's time to cable manage, which is part science and part art. Use the provided straps and zip ties to tie down cables and store excess cable in the bottom of the case. Locate the 24-pin power cable and connect it to the 24-pin extension cable. Do the same for the CPU power supply cable. If you don't have the cable extensions, route the PSU power cables through and plug them directly to the motherboard. We also want to connect the 3 case fans to the fan splitter cable. And finally, plug the front USB 3 cable into the ribbon extension. Now, we can reassemble the case. Okay, now that the build is complete, let's connect up the peripherals. So we can plug the dongle for our wireless keyboard and mouse into one of the top USB 2 ports. Next, the LG display. I've connected the included HDMI cable to HDMI 1 on the display and attached the power cord. Now I can attach the HDMI cable to the motherboard HDMI port. Finally, if you have a wired Ethernet connection, you can plug in your Ethernet cable. If not, you can use a USB Wi-Fi dongle like this or even a PCIe Wi-Fi card. I'll leave links to some options below. Finally, let's attach the power cable and we're ready to power it up. Make sure my power supply is on and press the power button. And there we go. Now, I've already set all the UEFI settings, installed and updated Windows, and installed all the necessary drivers. Again, check the description below for a link to that video, but right now I want to show you that despite not having a dedicated graphics card, this is still a very powerful and very capable PC that will absolutely slay common workloads for most PC users. In fact, over 85% of typical PC users don't execute workloads that require dedicated graphics. And the majority of off-the-shelf home office PCs sold from companies like HP, Dell, Lenovo don't have dedicated graphics cards and run on the CPU's integrated graphics, like this PC does. So to demonstrate this, I'm going to run PC Mark 10. This is a full suite of benchmarks that'll test the PC's ability to run a bunch of very common home office PC tasks. Now, the entire benchmark takes about 30 minutes to complete, so I'll just highlight the tests it runs. Add a webcam and you can teleconference. No problems web browsing or streaming video. Working from home is covered. Content creation is good to go with photo editing and even some video editing. The system is even capable of some 3D visualization and rendering. And for those of you in the know, here are the scores. Okay, that was just a quick demonstration of some of what this PC is capable of for most users. But what if you're one of those 15% of people who need more power? Maybe you do more serious video editing using more GPU intensive effects or grading, or you do more intensive 3D design and want to take advantage of the hardware acceleration a graphics card provides, or you're just a person who wants to log off their Zoom meeting and log on to some Call of Duty. Then you'll need to upgrade the system with a dedicated graphics card, and I'm going to demonstrate that today with this Gigabyte GTX 1660. Now, I went with this because, well, I have it. I'm not special. I can't buy new graphics cards either, but also because if you really need a card right now, this is probably one you can find for a relatively decent price. This card launched with an MSRP of about $220 to $230 US. Now, currently, all graphics cards have been hit with a 25% tariff, so that kicks the cost up to about $280 or $290. And that's if you can find them for retail sale. This morning, I found one of these exact cards on eBay with a buy now price of $306, so not horrible. This card is also a great choice for content creation, offering CUDA acceleration and a very good onboard NVENC video encoder. And it's a very capable 1080p gaming card. But despite what card you're able to acquire, they all install the same way, so let me show you how that's done. First, remove the second and third PCIe expansion slot covers. Next, ensure the PCIe retention tab is depressed. Now, line up the notch on the PCIe slot on your graphics card with the catch on the PCIe slot and slide the card into place. Using the thumb screws you removed, secure the card. Now locate your 6+2 PCIe power extension cable, and again lining up the catch with the notch, plug it in. And feed the excess through the bottom grommet of the case. Finally, locate the PCIe power from your power supply and connect it to the extension cable. Again, if you're not using extension cables, route the power supply cable through the grommet and connect it directly to your graphics card. Okay guys, the build is complete and upgraded. Now we have a very capable all-purpose PC that can handle pretty much any task you can throw at it. Again, links to all the components plus alternatives will be in the description below, as well as a link to part 2 of this video where I'll go over step by step how to set up the UEFI settings, install and update Windows 10, install all the necessary drivers, and even some utilities so you can do things like sync and change the color of the lighting. I really hope you learned something. That is why I do what I do. If so, please remember to click that like. It really does help get this video out to more viewers. If you did enjoy this build guide, but it's a bit outside of your price range, check the description for links to some less expensive but still capable build guides. And for future builds, be sure to get subscribed. I hope to see you in the next one. Until then, stay safe.